So, good morning, students. In today's video, we are going to cover this topic, which is thermal and physical state of the Earth's interior. Okay, so we will see the thermal and the physical state of the Earth's interior. First is the temperature. So, the temperature increases with the increasing depth. So, firstly, we will talk about the temperature inside the Earth's interior. So the temperature increases with the depth. As we go deeper into the Earth's interior, the temperature increases. The temperature increases at a rate of 1 degree Celsius for every 32 meters. So the rate at which the temperature increases is 1 degree Celsius for every 32 meters. As one goes deep inside the Earth's interior, the core layer has 4000 degrees Celsius temperature. So we know that we have seen in the previous video that we have discovered three main layers inside the Earth's interior with the help of seismic waves. So here's the core, here is the mantle, and here upper is the crust. Okay, so we can see this core has the temperature of 4000 degrees Celsius, which is a lot. So it is very hot. 48 kilometer asthenosphere, 1200 to 2000 degrees Celsius. So we will see that when we go, this is the Earth's surface, as we go like 48 kilometer deep into the Earth's interior, the temperature asthenosphere, so that layer is called asthenosphere, and it has temperature of around 1200 to 2000 degrees Celsius. Okay, and volcanic eruptions 48 kilometer inside the Earth's interior. So scientists have found that the volcanic eruptions happen, and the magma that comes from the volcanic eruptions is found nearly around 48 kilometer deep inside the Earth's interior. We can measure temperatures reliably only up to 8 kilometer. So we will, like, if you have we have found that the means we can find very accurate temperature at around 8 kilometer inside the Earth's surf interior. Beyond 100 kilometer, fewer uranium and thorium minerals, less heat produced. So beyond 100 kilometer, it is it is very hard to, means the temperature is not increases that much. Let me clear this point. I hope these all points till now is clear to you all. Let's discuss this last point, that this is the Earth's surface. The 100 kilometer till here, we can measure the temperature and the very like reliably, and the temperature is increasing at a very fast rate. But beyond 100 kilometer, the temperature is increasing at a relatively slower rate. Why? Because uranium and thorium, these are two radioactive metals, we can say. They are very few, and because of them less heat is produced. So that's why the increase in the temperature is slower beyond 100 kilometer. So let's summarize this so that you can create an image of this particular topic of the temperature inside the Earth's interior. So basically we have studied that the temperature increases as we go down deep into the Earth's interior. First 48 kilometer, then 100 kilometer, then more than 100 kilometer, beyond 100 kilometer. So first 8 kilometer we can measure the temperature very perfectly reliably, and 48 kilometer the temperature is we can say this is called the asthenosphere, and here the magma and lava that cause the volcanic eruptions are generally present. And yes, and this is 100 kilometer. Here the urine beyond 100 kilometer, the increase in the temperature slows down because uranium and thorium, these two radioactive metals, are means fewer in number, and the core's temperature is 4000 degrees Celsius, and this asthenosphere, that is like 48 kilometer deep inside the earth's surface, has 1200 to 2000 degrees Celsius temperature. Okay, and now let's talk about the pressure. So pressure uh, inside the earth's surface, density increase with depth, not only because of what, just a second. Huh. Yes, so density increase with depth not only because of what rocks are made up of, but because the deeper rocks are under much greater pressure from the layers above. So the density inside the earth's interiors increases with the depth, and the reason is not only that what rocks are made up of. Okay, there's another reason that the density increases, and that the reason is the deeper rocks are under much greater pressure. Means the like for example, this is the core, and this is our mantle, this is the crust. So the core has much pressure than the above layers because these layers put pressure on this core. So here the metals, whatever metals are present, will be more denser. Why? Because they get pressure from the above layers, and due to that pressure, the particles of these matter comes closer and closer, and because of that the metal become denser. So density increases with depth not only because of what rocks are made up of, but because the deeper rocks are under much greater pressure from the layers above. Pressure can increase rock density but only up to a limit. So like the pressure can increase the density of rocks by bringing them closer to each other, but only up to a limit. Only up to a limit, that is, there is only some threshold value. Threshold value means a minimum value. Above that pressure cannot increase. The core's extreme density comes from its metallic composition, not pressure alone. So the core's the core's extreme density comes from the metallic composition. Okay, metallic composition, as well as from the pressure from above layers. Okay, so metal composition plus the pressure, so these both leads to the uh, increase in the density of the core. So iron and nickel core is confirmed by geological and magnetic evidence. So we have found by the geological, that means we have found out the samples of rocks of metals, sorry, basically not rocks, metals are present inside the earth's core, and those metals are iron and nickel, and with the magnetic evidence also. So what does this magnetic evidence means? Let me give you some explanation of that as well. So basically magnetic evidence is when the electric current is generated, the magnetic field is made. Okay, so basically these iron and nickels are present inside the earth core, and they are in liquid form. Okay, because you can because we know that the core's temperature is 4000 degrees Celsius, so temperature is very high, and because of that these are in liquid form and they are moving. So that movement causes the electric current, and that electric current causes the magnetic field around the earth. This is earth, and magnetic field is created around the earth. A crystalline rock layer sits above it, forming the deeper interior structure. So a crystalline rock layer is sitting above the core and forming the deeper interior structure. So not that important. And now lastly we will talk about the density inside the earth's interior, average density of the earth. So the average density of the entire earth is 5.5 gram per centimeter cube. So this is of course the density unit. So if we take the average density of the entire earth, it's 5.5 gram per centimeter cube. This means that if you take the whole earth crust, mantle, core and average it, you get 5.5. So if we take these all and average out the density of these layers, it will be 5.5. Continental crust, that means the upper layer. The continental crust uppermost surface layer has a density of around 2.7 gram per centimeter cube. It is made mostly of granitic rocks rich in Cl, silica plus Al, aluminium. These minerals are lighter, so the density is low. So the continental crust has the density of 2.7 gram per centimeter cube, and it is made mostly of the granitic rocks, and those granitic rocks are basically silica and aluminium, and these minerals are much lighter and less denser. Okay, so sorry, so let's talk about the crust. It is relatively less denser just because not so much pressure and the metallic composition like the sea and the rocks, basically the Cl, the silica and aluminium is lesser denser. And yeah, density increases with depth. As we go deeper into the materials generally become heavier and denser. This is because deeper layers contain heavier elements and experience greater pressure. So density increases as the depth increases. So basically, as we go deep into the earth's core, or you can say earth's interior, the heavier metal elements are present and the greater pressure is present. So density increases with the depth. Why? Two reasons: because of the metallic composition and the pressure from above layers. Mantle layer sima. Below the crust is mantle made mostly of sima, silica and magnesium. It is heavier than Cl, so its density is about 4.3 gram per centimeter cube. So after crust, after crust, mantle layer is present, and it is made up of sima, that is silica and magnesium, and it is heavier of course than Cl, and has density about 4.3 gram per centimeter cube. And the last is the core layer, and the temperature is 4000 degrees Celsius, and the deepest region is the core. It is made up of knife means nickel, and Fe means iron. These metals are very heavy, as we know that iron and nickel are heavy metals. The core's density is so high that it can be around 10 to 12 times denser than water. This is why Earth has high average density overall. So because of the core, the overall Earth's density is very high. Okay, so Earth's density is very high because of the we can say core layer, because core has heavy metals, and also the pressure here is more because of the fall means upwards layers like the mantle and crust. So I hope all these three topics we have covered in the subtopics we have covered in this topic: thermal and physical state of the earth's interior, that is temperature, pressure and density. So I hope these topics are clear to you all. If you have any doubt, freely comment in the comment section. And the homework for today is to make an image in your mind explaining this concept. So that's it for this video. Thanks for watching.